Hello. Today I'm discussing a course called Fundamentals Fundamentals of Artificial Intelligence. We have a module in this course which is History Trends and Future of AI. AI, first and foremost, is the development of machines that can perform required tasks that require human-like intelligence. So, the historical spark of AI involves scholars like Leonardo da Vinci, who sketched the first humanoid in the history of AI, and then Alan Turing, who published a popular paper which discussed the Turing test. And then there is also John McCarthy, also played a significant role in AI. So AI has reached milestones and trends. So you have a timeline approach to these milestones. First, starting from the 1940s to the 2000s. The first range was between the 1940s to the 50s, whereby we had the Turing machine by Alan Turing and early computing. In the 1956, we had the Dartmouth Conference, where AI got its name, artificial intelligence. And then we also have in the 1960s to 70s, there was introduction of symbolic AI and expert systems. In the 1980s, we had the expert systems boom. This was the boom of the expert systems and the knowledge-based AI. In 1997, we had the deep. We had also AI introduced in the 2010 to 2020. We had machine learning, deep learning, and NLP breakthroughs. NLP includes ChatGPT and other expert systems or intelligent systems. So the history is related to a type of intelligence, which is the logical mathematical intelligence, which involves reasoning across milestones, problem solving, and planning. We also have the linguistic intelligence, whereby we have the NLP's applications like chatbots, translators, and then summarizations. These are all advancements over the years. We also have a debate between weak AI and strong AI, whereby the weak AI the weak AI acts like humans in its activities. And then the strong AI has not yet been achieved. We have the second module in this course, which is problem solving and heuristics. Problem solving involves three key elements, which is states, operators, and then the goal. A state involves the possible configurations of the environmental. Operators involves actions that are done in the state. And then you have the goals, the desired outcomes, or the desired end states. So problem solving has searches like state space search, and problem solving is also related to the logical mathematical intelligence, which involves structuring problems formally, designing operators. So here we are giving examples of games developed using the problem solving and heuristics. We have the puzzle game, we have the maze solving game, we have the hill climbing. These are all developed using a problem solving technique. So in this slide relates problem solving and heuristics in relation to my problem domain, which is mosquito powered trap. Problem solving by search. So we have the informed search and then the uninformed search. So uninformed search does not use the public domain to solve a problem, while the informed search uses the public or problem domain to solve a problem using heuristics. So we are having types of intelligences related to the game playing and such, which is the spatial intelligence, which involves understanding and navigating search trees. We are planning moves in games and steps in problem solving. So we have games like TikTok, and then we have problem solving techniques like alpha beta pruning and graphs. These are all employed in problem solving by search. This is to relate the problem domain, which is the iPad mosquito trap, with problem solving by search. Now we have an initial step, which is detection of mosquitoes, a both step, which is to eliminate the harmful mosquitoes. We also have operators like detect mosquito via wing baits, classify mosquito using AI module, among others. And here we shall also use the spatial intelligence, which is among the 8 types of intelligence. Moving forward to the next module, which is knowledge representation and reasoning. Here we shall compare human versus the machine knowledge. We shall note that human knowledge is flexible, context aware, can reason with incomplete information. This is a human, it's different from a machine. And then the machine knowledge is formalized, rule-based, needs explicit representation. Yeah. We are introducing symbolic representation and first order logic. So in symbolic representation, we shall majorly use propositional logics, which are just simple statements. And then if we are to move further to the first order logic, we would use predicate logic. So still in knowledge representation, we are looking at the types of intelligence involved, which is the linguistic, which involves expressing knowledge and rules in symbolic language. And then we also have the interpersonal intelligence in AI. First order logic, as I introduced earlier, would use predicate logic, which involves quantifiers, a goal, domain examples. So let's introduce a concept which is inference. So inference will involve deduction, deriving new truths from known facts and rules. So we'll have soundness, completeness. These soundness and completeness are in terms of revolution, whereby revolution is sound and revolution is sound and revolution is not complete. Moving forward, still first order logic uses logical mathematical intelligence, which involves systematic derivations and tools, reasoning through chains of inference, make decisions as we've seen earlier. Reasoning and uncertainties following some reasoning and probability modules as listed. We also introduced a new module called planning. Planning is the process of sequencing actions to achieve a specific goal. Sequencing actions to achieve a specific goal. So planning will involve the initial stage, the goal state, operators, and then the plan. Because we've seen earlier that these three stages in the problem solving by search. So we shall employ the same here. Then we move forward. In this case, we shall use a type of intelligence, which is the bodily kinetic intelligence, which sequences and executes physical actions effectively. In relation to our mosquito-powered trap, AI-powered mosquito trap, we shall look at the steps, the plan structure, which is detection of mosquitoes in the area, classifying each mosquito using the AI, and then target the harmful mosquitoes with a laser. Furthermore, we look at decision making after planning, which involves the benefit or the risks or uncertainties involved. Then finally, as a wrap up, there is machine learning, which involves supervised and unsupervised learning, whereby supervised learning includes training a model to classify mosquitoes as harmful or harmless using labeled wing-beat data, and then unsupervised learning to cluster wing-beat patterns to detect unknown mosquito species or behaviors. Here we shall see intelligences like the logical mathematical intelligence and then the naturalistic intelligence. Thank you for listening, my dear viewers.